Okay, so today we're going to continue our look at some of those basic algebra facts that we've been working with. Remember last time we were here, we looked at what? At radicals, or also known as roots. Yeah, taking the square root or cubed root of numbers and variables. Yeah. So today what we're going to do is we're going to look at expanding single brackets. Okay. Most of you are familiar with this task and have done it plenty of times, but I will guarantee you that many of you do not know that there is an actual order in which you should attack these. And so we're going to talk a little bit about that, and then we'll do some examples so that you can see them properly. Because tomorrow, the next lesson, what we're going to do is we're going to learn how to take them apart. So today we're going to expand them, and then tomorrow we're going to learn how to factorize them. Okay? So let's look at what that means. Expanding brackets. Oh, super easy. Okay? Expanding brackets. What that means is that you're going to be eliminating the brackets by doing the work, doing the math. Remember the order of operations? When do you do brackets? First, always. Yes? Good. And so you need to understand how that works. Pardon? Expanding brackets. Okay, so here we go. There are 3 steps for expanding brackets. And most of the time, you're only going to see one of them being done. There's one of them that happens more often than the others, which is good and bad. It's good because it's also the easiest part. It's bad because it's also the 3rd step. And if you only ever do the 3rd step, then what's going to happen for steps 1 and 2? You're going to forget them when they do happen. Okay? So you've got to be careful. So you need to make sure that you memorize these steps and in order, even though the first 2 don't occur very frequently. All right? So here we go. The first thing you need to do is look inside the bracket. Now again, this is very rare that there's anything to do inside, but if there is, you need to simplify inside first. Remember, simplify is that all-encompassing math word that means do the math. You follow the order of operations. So sometimes there may be some like terms to combine, sometimes a little multiplication or some division, whatever. If there's anything that you can simplify inside, then you need to. And you need to do that first. Okay? The second thing, which is the one that causes most students the most trouble, so you need to remember, is look for an exponent on the bracket. Now, I'm not talking about an exponent on the inside, because we would have already taken care of that, right? If it could be done. I'm talking about an exponent on the bracket, and I'll show you exactly what I'm talking about in just a moment. We'll look at an example that has all 3 parts. Okay? Right? And then finally, the 3rd and last thing, which is the most common thing, is to deal with the coefficient. So multiply by the coefficient. Remember, coefficient is just a fancy word for a multiplier. And if it's a term, the coefficient is always which part? The number. Excellent. Good job. Okay? Is always the number part. But remember, coefficient doesn't mean number. It means multiplier. So your multiplier for the coefficient for a bracket can be a number. It can be a variable. It can be a combination of both. It can even just be a sign. Any of those things can be a multiplier. And we know that they're a multiplier because they're immediately in front of the bracket. Okay? No plus or minus separating. Now, if you do have a plus, that plus actually becomes the coefficient. We'll talk about that. If you have a minus, that minus becomes a coefficient. But if you have something like 3 plus the bracket, the 3 has nothing to do with the bracket at all. Okay? All right. Yeah, I ran out of room a little bit there. So let me just write down an example of a bracket. I'm going to use nothing but letters. Just because I don't want you to think about these in math terms, I just want you to think of which pieces are which. So say we have sum A in front of x plus y raised to the nth power. Okay? Now again, we can't do any of this math because I don't know what any of those things are, right? It's just to show you where each piece is. The first thing you need to know is that this entire thing is one term. Everything, including the exponent. That whole thing is one term. Now, inside the bracket, there's more than one term. Do you agree?
Yes.
Yes? But because it's enclosed in the bracket, it's like being in a box, right? We've talked about that before. So it's all one term, okay? And imagine this, it's called a bracket term. Why might it be called a bracket term? Because it's got a bracket in it, right? There you go. All right. Okay, so we're going to always treat them as one term. Okay. Now what I want to do is I want to look at each piece of the bracket. Okay? If I say inside the bracket, what I mean is these pieces here, the x plus the y. Right? Because literally they're inside the bracket. Okay? If I say the exponent, what am I talking about here? The n. Okay? And finally, if I'm talking about the coefficient, what am I talking about? The a. Now notice, it's the coefficient because it's right in front of it. It's the multiplier. And I know that it means multiply because if you stick a number or a letter or a sign or anything right in front of a bracket, that always indicates what operation? Multiplication. So it's the coefficient. Okay? So we have the inside. This is the exponent. And the a is the coefficient. Right? It's important you understand each piece. And it is critical that you deal with each piece in order. Now, it's not going to look like it at all times. But again, remember, if you're used to taking shortcuts, some shortcuts can come back to bite you. So, you don't use that expression here? Okay. Okay. So, think about it. Inside, then what? Exponent, then what? Coefficient. Okay? In that order. Which one is the most common that you'll be doing the most? The coefficient is the most common. But don't just jump to it first, because if you do, then you can really create yourself some problems, especially if there's an exponent. The inside is more flexible, but the exponent is totally inflexible. Okay? All right, so we're going to look at some examples. Which ones do you think I'm going to do? The even ones. Which ones does that mean you're going to do for homework? The odd ones. We're on page 17 here. Okay. Right. Okay, so let's look at some examples. Now you need to be careful with remember your steps for multiplying terms, because they're going to hit you with everything here. Right? So we have 6x times 2 minus x. And we're told to simplify it, or it's actually expand and simplify. Right? Expand means that we're going to end up with a bracket, and expanding it means get rid of it. Don't really need a special word for it. We could just call it simplify. Okay? So here I have a bracket. Notice all of this is how many terms? One term. So we only have one term up there. So I've got to get rid of the bracket. So the first place I look is where? Inside. Inside the bracket, I have 2 minus x. Can I subtract an x from a 2? No. So can't do anything inside. Is there an exponent up here on the bracket? No. Is there a coefficient or a multiplier? Yes. It means the coefficient in this case is what? 6x. It's both of them. Okay? 6x. What that means to do is to distribute that 6x to every term inside the bracket. So we're going to take the 6x times the 2, then we're going to take the 6x times the negative x. And do it piece by piece. Unless you're really good at this, always do it piece by piece. Remember, to multiply terms, first we do the sign, then we do the coefficients. What do we do to the base? Keep the base. And if there are any exponents, what do we do to them? Add the exponents. Excellent. And there will be some exponents on these, okay, in some of them. Here we go. So we'll do the 2 first. So positive times a positive stays a positive. 6 times 2 is 12. And x times nothing just stays x. All right. Now we're done with the 2. Now let's move to the second term. Positive times a negative is a negative. 6 times nothing just stays 6. And x times x is x to the second or x squared, either one you want to call it. And there you go. Now, since we've done all 3 steps, the bracket is gone, right? Okay, so make sure you don't leave the bracket. It's just like the radical. Once you've used it up, it's gone. Don't leave it. Looks good? Okay, here we go. So let's look at another one. 7 times 3x minus 4 plus 12. We're told to simplify this, and the first thing we look for when we're simplifying anything are brackets, right? Do I have brackets? Yes. Is everything up there part of the bracket? No. I'm about to give you the best piece of advice you can ever have. Here is the bracket. It starts with the 7, goes all the way to the end of the bracket. So is that positive 12 part of the bracket? No. Then bring it down to the next line. If you need more paper, I will be happy to give you more paper. All right? But don't try to save paper and then forget writing things down. Okay? Be very careful. Now let's go back and deal with the bracket. So if it's not part of the bracket, bring it down to the next line because you're not going to use it yet, are you? And some of these brackets can get very complicated. This one's not. So going to the bracket, where do I look first? Inside. I have 3x minus 4. Can I do 3x minus 4? No. Then I look for an exponent. And that's the one you're going to forget most, guys. And it doesn't, because it just doesn't happen that often. But when it does, boy, it's a big deal. No exponent. The last thing I look for is the coefficient. And I have a coefficient of 7, which means I need to take that 7 times both of the terms inside. So positive times a positive is a positive. 7 times 3 is 21. Nothing times x just stays x. Piece by piece. And of course, some of you are more sophisticated than others and more advanced, and you can do that faster. I'm going to do it piece by piece just to remind you. All right? Positive times a negative is a negative. 7 times 4 is 28. And there is no variable on that one. Now, I've done all 3 steps, so notice that the brackets are gone. Right? We've used them up after you do the 3rd step. Now, am I done with this problem? No. Nope. Because if you'll notice, there are 2 number terms. So those 2 number terms can be what? Combined. Yeah, there you go. So 21x won't change. What is a negative 28 plus 12 going to leave me with? Negative what? 16. Okay? The signs are different, so you keep the sign of the larger and subtract the numbers. And there is your completed answer. So there will be things that are not part of the bracket, and they will not get used until after you've eliminated the bracket by expanding it. Okay? Looking familiar? Good. Any questions so far? Okay. All right. I'm looking at my examples first. I'm looking for there are a couple of things that will catch you up here. Let's look at another one. I'm just going to make this one change. I'm going to change one of the problems. So don't look at it and say, but Mr. Stuff, that's not what it says. I'm changing it on purpose. Okay? So what I'm going to do is, look at number 6. We have 10x and 7 minus 2x. Yes, I have left off the 3, but I'm doing it on purpose because I want to show you something that happens quite frequently. All right? First of all, we're told to simplify this. The first thing that means apply the order of operations. So the first thing I look for are brackets. Do I have any? Yes. Where does this bracket actually start? With the negative, exactly. The minus, remember I told you that the coefficient can be just a sign. So whatever's right in front of the bracket is always its coefficient, even if it's just a sign. So what about the 10x? What am I going to do with that? Just bring it down, right? Now let's go back to the bracket. So first I'll look inside. Can I subtract a 2x from a 7 inside? Nope. Is there an exponent? Nope. Is there a coefficient? Yes. But the coefficient is just a negative. Now, you know that means there's a 1 there. So what we're really doing is multiplying by negative 1. But you don't even have to think about it like that. You can do a negative times a term, right? So watch what happens. So negative times a positive turns it into a negative. Nothing times 7 just stays 7. Really, it's a 1 times 7, but who cares? Now we'll do the second one. Negative times a negative becomes a positive. And nothing times 2x just stays 2x. So multiplying by negative didn't change the numbers, but it did change all of the signs. Yeah. Right? Okay? So keep in mind that, now, if you wanted to rewrite it as negative 1 times 7 minus 2x, if that makes more sense to you, then do it. But you don't really need to. You can take a negative times a term, right? Okay? Whatever you prefer, whatever makes your life easier is what you should do. Are we done? Why not? Yeah, we have some, what are they called? Like terms. So we have 10x's plus 2x's makes what? And what about the negative 7? Just comes down, stays the same. And there's your completed answer. Okay? So you can have, remember, always think about where the bracket starts and stops. Right? So you'll know which things are pieces of the bracket. Think it changes if I have 2 brackets? Nope. You'll just take care of each one separately. So let's look at something like number 12. So we have x. You like number 8 better?
Yeah, how do we...
Okay, well, I don't care.
Oh, we took the... We just imagined the...
No, I changed it because I wanted it to be a different problem. Yeah. So I took the 3 off because I wanted to show you that negative thing. Because you have one in your homework, but you didn't have one in the examples. Okay, so number 8 you want. Okay, so 2 times 9x plus 4 plus 3 times 5 plus 2x. We're told to simplify this, so the order of operations says the first thing I need to look for are what? Brackets. Do I have any? Yes. This time I have how many brackets? 2. So where does the first bracket actually begin? At the 2, and it stops right there in front of that plus. Because remember, every time you see a plus or minus, you know that's the beginning of the next term. Now, I ignored the one inside the bracket because since it's inside, it's part of the bracket term. Where does the next bracket actually begin? At the plus 3. There you go. That sign needs to go with it. So it actually begins with that plus. So don't forget the signs. Okay? Now, let's go ahead and take care of the first bracket. Look inside. 9x plus 4. Can I do that? No. Is there an exponent on the bracket? No. Is there a coefficient? Yes. The coefficient of positive 2 means multiply everything inside by positive 2. So first we'll take it times the 9x. Positive times a positive is still a positive. Do you need the bracket plus? No. Not there, but do you need it later? If any other term after that? Absolutely. Okay. So again, if you're a sign rule breaker, then write more than you need. Okay? 2 times 9 is 18. Nothing times x just stays x. Okay? Done with that term. Let's do the next one. Positive times a positive is a... Do I need that positive?
Yes.
Absolutely. Anyone except the first one you absolutely must have. And 2 times 4 is 8. Done with the first bracket. Now let's move to the second one. Inside is 5 plus 2x. Are those like terms? No. Is there an exponent? No. Is there a coefficient? Yes. What is the coefficient? Make me proud here. Positive 3. Excellent. Thank you. We're going to take that times everything inside. So we'll start with the positive 5. Positive times a positive is a positive. 3 times 5 is 15. Done with the 5. Now let's do the other term. Positive times a positive is a positive. 3 times 2 is, and nothing times x just stays x. Now, of course, if you said 3 times 2x is 6x, that's perfectly acceptable. But remember, I'm doing it for effect so that everybody can see where everything is coming from, right? Okay? Now, done?
No.
Why not?
Got some light terms.
I have some like terms. First term is an 18x. That's an x term. Do I have any more x terms? Come on. Plus 6x. There you go. So what's 18x's plus 6x's going to make? Positive 24x's. And because it's the first term, I don't need the plus, right? Done with my x terms. Now I have 2, what are they called? Number terms. Yeah. So positive 8 plus 15 is going to make 23? Okay.
It is.
Yeah, I was like,
Do you have to put plus 23? Well, okay, there was a plus.
There you go. There you go. And remember, it's not optional after the first term. You have to say it. Because if I just stuck 23 down there, that means I'm multiplying those things, right? Sorry. Just being, I'm a math teacher. I got to get some joy out of life.
Oh, yeah.
Okay? So there we go.
Number 10.
Number 10?
Yeah.
Okay? No problem. I can do these all day. 9 times 2x minus 1 minus 5 times 3 minus x. Okay, number 10. First thing I look for are brackets. Do I have any?
yes.
How many?
2.
2. Where does the first one begin?
9.
At the 9. 9 goes all the way to the end of the bracket. Where does the second one begin? With the negative 5 and goes all the way to the end. Okay? Now, so we'll do the first one first. I'm going to break them in two because just so you can see that. You don't have to do that. All right? Looking at the bracket, first I look where? Inside. I have 2x minus 1. Can I combine those?
Yes.
Nope. Be careful. Is there an exponent? No. Is there a coefficient?
Yeah.
Yep, it's a positive 9. So let's multiply everything inside by positive 9. Positive times a positive is a positive. 9 times 2 is, and nothing times x just stays x. Good. Now let's do the second term. Positive times a negative is a? 9 times 1 is 9. Okay? Now, that bracket's gone. Let's move to the next one. 3 minus x inside. Can I subtract an x from a 3? Nope. Is there an exponent? Nope. Is there a coefficient? Yep. It's negative 5. So I'll take it times both of the things inside. First one, negative times a positive is a? 5 times 3 is? Okay. Done with that one. Now let's do the second one. Negative times a negative is a? And 5 times x is? 5x. It's good? And now I'm done, right?
No.
Why not?
Because you got some like.
Good deal. The first term is an x term, and here's another x term. Positive 18x's plus 5 more x's is going to make
23x.
positive 23x's. But do I need the plus in front? No, because it's the first term. Negative 9 minus 15 is going to make?
Positive 24.
Be careful.
Plus.
Negative 24.
Negative 24.
Because we're combining, not multiplying, right? If you're combining, if the signs are the same, you keep the sign and add the numbers. No, 2 negatives never make a positive. Who said that?
In multiplication.
Okay? No. When you multiply 2 negatives, the answer is a positive. There's no such thing as 2 negatives make a positive. That is the single biggest sink your algebra boat rule that you can ever have. All right? Negative times a negative makes a what? Negative divided by a negative makes a what?
Negative.
Okay.
Yeah, so if you have -4 times -4.
In other words, if you don't include the operation, then you don't have a rule, right?
-4 minus -4 is -8.
There you go. And that two negatives make a positive rule really causes you trouble. You have to have an operation. Okay? Yes?
We haven't done one with an exponent on the bracket, but there's not one on our exam design.
Not yet. No, we'll deal with that later. Okay?
Are we number 12?
Can we do number 11 actually?
No, I'm not going to do number 11
Why not?
because it's in your homework.
But if we were
Let's
to
swap it.
I
I
don't
don't
think
think
it's
it's
12.
That's not.
I just have a question. Can we number 12?
I mean, I did it, but I don't know.
I just have a question.
Let's do number 12, and it's gonna give you something that's much like number 11.
Can we swap 11 for 12? If you don't do 12, but we do 11.
No, let me do number 12, and you're gonna see what you have to do for number 11.
Same question. See how? See how it's like 2x is right next to the bracket. Is it like just don't use the term, or is it looking at like the algebraic term? Is the
Well, hold on. Once you see this one, you'll see. Once you see this one, you'll see how that works. Okay. Well, hold on. All right. Here we go, guys. What the first thing I look for are what?
Brackets.
Do you have any? 2. All right. Do you want me to put plus an x squared at the end to make your life happier?
Yeah.
All right. Oi.
Oh,
Oi.
actually, yes.
Here we go. X. All right. So how many brackets do I have?
2.
I've altered it to make it more like number 11. 2. Where does the first one begin?
X.
With the x. Where does the second one begin?
Negative
7. What about the plus x squared that I added that wasn't in the problem? Bring it down. I've changed the problem because y'all are freaking out about number 11, so I made it look more like number 11.
Freaking out. It's just that. What do you
All right. I did too.
That's number 12.
I mean,
Here we go.
like understandable.
Here we go. So first we'll start here with the first bracket. 1 minus 2x. Can I do 1 minus 2x? Nope. Is there an exponent on the bracket? Nope. Is there a coefficient? Yes, it's an x. So positive times a positive is a? And x times 1 is 1x or x. Now, if I was doing this, I would probably leave the 1 there until I'm done. Because you know there's going to be more in a minute, right? You know they're going to be like terms. So now we'll take the x times the negative 2x. Positive times a negative is a? Negative. Nothing times 2 just stays. And x times x makes x to the second or x squared.
Wait, can I just ask a really quick question?
Mm-hmm.
For number 11.
No, I'm not on number 11. If you have a question about this one, I'm doing. You ask questions about what I'm doing, not what.
I just want to know which one we do first and which one.
Here we go. Now, I'm showing you right now. I changed this one so it matches number 11 pretty much. All right. I'll show. Okay, we'll talk about it. Okay, now, next bracket, 3x plus 4. Can I do those? No. Nope. So now we'll just take both of these. Negative times a positive is a? 7 times 3 is? X times x is? There you go. Now let's do that times that one. Negative times a positive is a? 7 times 4 is? And x times nothing just stays? Oops, and I put that on the wrong line. Okay? Plus x squared. Okay? Now, gotten rid of the brackets. What's next? Combine the like terms. This is an x term. Do I have any more x terms? Yep. So one of them, nope, they're not all x terms. Be careful. 1x minus 28x's leaves what? Minus 27x. Thank you. Then I have an x squared term, another x squared term, and another x squared term. Remember, that's 1 if there's no number in front. So negative 2 of them minus 21 of them makes negative 23 plus 1 more makes negative 22x what? To the second. Combining these 3 like terms. Negative 2 and negative 21 make negative 23. Plus 1 makes negative 22. Right? If that's an issue for you, take them off to the side. Oops. Probably should line them up better, though. Okay? All right. Now, on number 11, before you even begin, you have 5x squared and x squared. You have two choices. You could combine those two from the very beginning, but really, in the grand scheme of things, what should you deal with first? The bracket. And then combine your like terms at the end. Now, you can get away with combining those like terms first because they're not part of the bracket. But if you get used to doing that, sometimes it can come back to haunt you, because what if that 5x squared had been in front of the bracket? Could you combine it with anything then? No, because it's the coefficient of the bracket. So if you get used to thinking about like terms first, then sometimes it can cause you trouble, right? So I would recommend that you take care of the bracket first and then combine all your like terms at the same time later. Okay? But it will technically make no difference to the answer on that one. Okay? All right, so that's where we're going to stop today. We're going to take it nice and easy today and tomorrow.
Oh, yeah.
Okay? Okay, you bet. Let me just stop the recording.